Good afternoon, everyone. Welcome back. Thank you for joining us here for the first ever and hopefully last virtual Asphalt conference. I want to give a huge shout out to Dale and the conference committee for taking the time to put this all together for us today. For those of you I have yet to meet, I am Carrie Burke. I'm the Director of Marketing and Member Services for the Associated General Contractors of North Dakota. Many of you on here right now are members, but for those of you who aren't, the AGC is the only association 100% devoted to representing the interests of commercial contractors in our state. We advocate, we educate, and right now we are busy legislating. Russ Hansen, our Executive Vice President, is at the Capitol every day, watching, listening, testifying, promoting bills favorable to the construction industry, such as the bonding bill that would help to fund critical infrastructure projects, and opposing bills that would be onerous to our industry, such as the one that would increase unemployment insurance premiums for all of us working in seasonal industries like construction. By the way, contractors in North Dakota pay one of the highest, if not the highest, unemployment insurance premiums in the country, and the AGC of North Dakota is fighting to keep those premiums from being raised even further. Prior to beginning my work at the AGC, I was a dirt girl. I am the third generation in a dirt moving, road building, family owned construction company. So to be involved with the Asphalt Conference is not only an honor for me, but also very educational. I consider myself extremely lucky to have been born into the North Dakota construction industry, and I want to thank you all for being a part of the great industry that I call home. A couple of housekeeping items before I introduce our first speaker. This is being recorded, and it will be posted on the LTAP site sometime next week, along with all the presentations. The PowerPoints that you're seeing here today, it will all be on there. Q&A, please ask questions. That's what our presenters are here for. Use the Q&A function to shoot your questions over to us, and we'll see if we can get you some answers. If we don't have time for all of the questions during the segment today, reach out to the presenters. Each and every one of them have said, please contact me, ask me questions. That's what they're there for. We're going to switch up the, due to some technical difficulties, we're going to switch the agenda up a little bit today, and we're going to go straight into Josh Logarin. Josh is a young engineer from Lamar, North Dakota. He has been sifting through the carnage of some of the old methods we have tossed aside, and he's found some gems that he is bringing back to life. Josh is the highway superintendent and engineer for Lamar County. He started working with the county in 2018. Before that, he was with the North Dakota Department of Transportation Traffic Operations Section for 5 years, and then with KLJ for 5 years. Josh has experience in traffic signals and technology, highway safety projects, and all types of county and city construction projects. He graduated from NDSU, go Bison, with a BS in civil engineering. A warm Asphalt Conference welcome to Josh Logarin.
Yeah, thanks, Carrie. I just want to make sure, can you guys hear me and see my screen?
Yes.
All right, here we go. So yeah, as Carrie said, my name is Josh Logarin, the Highway Superintendent for Lamar County here in the southeast part of North Dakota. I've been here for about 3 years now, and just going to give a short presentation on some alternative types of asphalt seals. Dale came up with the title, but it's very appropriate, I guess. I'm the type of guy who likes to try new things and is always looking for the next big thing, and you know, find ways to better use our resources and do more, cover more miles with less money. But I've learned that sometimes it's not always a new thing that works best. Sometimes we, for one reason or another, we've gone away from something we've done in the past, and sometimes it's good to bring those back. They made sense then, and why wouldn't they make sense now? So that's really where this started. I've been a civil engineer now for going on 13 years, and these two seals, sand seals and auto seals in particular, I only heard about a year and a half ago. Maybe it's just me, maybe I'm just slow to the game, but I first read about sand seals. I was doing research on double chip seals, and I came across an early 90s federal highway document that talked about sand seals. And I asked some of the guys here at the county if Lamar County had ever done those. And there was one guy that said, oh yeah, we used to do them all the time 30, 40 years ago. That's what we did. And I asked him, well, why, what happened? He's like, I don't know. We just stopped doing them. So the more I looked into sand seals, the more I just thought it made sense for Lamar County to maybe give them another try. So the first thing that really grabbed my attention with the sand seal was the fact that you can use sand. And here in Lamar County, sand is readily available. It's the one thing we really don't have any use for, and there's piles of it all over. So it's cheap and it's easy to make. Here in Lamar County, we crush all of our own material, gravel and chips. And so not having to crush chips, which is very time consuming and hard on equipment, we can screen sand 10 times faster than make chips. So that was kind of the first thing that, like I said, that turned me on to the sand seal. And then also you're able to use a much lower application rate, less than half than you would on a chip seal. So you're able to cover more miles. It doesn't have as long of a service life as a chip seal, but we have miles that haven't been sealed in years because we can only do so many miles of chip sealing due to the cost. So being able to cover more miles was a real benefit to having a lower application rate. And then also I don't have any proof that this is actually a benefit, but what I have seen with the sand seal that we did was that you get penetration of the sand down into the cracks, these fine cracks that maybe you're not crack sealing. Since sand is obviously a lot smaller than chips, you're not just bridging over those cracks. The oil's down in the crack, the sand goes down there and just locks in. And I think it does a better job of actually sealing the road, even though, like I said, it is a much lower application rate. And then we can use the same equipment we use for chip seals. We do all of our own chip seals, and being able to try something new without buying any new equipment it just made it easy to give sand seals another try. So in 2019, we did the first sand seal in Lamar County in probably 3 or 4 decades. And we used the same oil that we use for our chip seals, CRS2P, but like I said, at a much lower rate, less than half the rate of a chip seal. We used it at a rate of 0.17 gallons per square yard. And that was kind of the average number that I found when I was looking up different projects that have happened in the past. So I just went with kind of the middle range, and that worked really well for us. It had good coverage and the sand stuck really well. We did fog seal it just like we would a chip seal. We fog sealed the sand after the project, after we did the final brooming. And we did it at the same rate that we do our chip seals, just over 1/10 of a gallon per square yard, with the same type of oil that we use for fogging our chip seals. The sand, we did screen our sand piles over a 3/8 minus or a 3/8 screen. So we ended up with 3/8 minus sand just to make sure we didn't have any oversized material in there. And we attempted to put it down at 25 pounds per square yard. We weren't entirely successful due to the sand being really wet, which I'll talk about in a few slides. But really that was the only issue we had with the project, was that we ended up putting down a lot more sand than I would have wanted to. And like I said earlier, equipment wise, we used all the same equipment. We did make a few modifications. The one individual that had been with the county when they did sand seals a long time ago, he retired about a year ago now. The only thing he could remember was that they took the tailgates out of the trucks because the sand would tend to want to bridge and not come out of the truck into the chip spreader. So we just took the tailgates out of the trucks. That's easy enough. And we didn't have any issues with the sand flowing from the trucks into the chip spreader, even with the material being really wet. And the oil distributor, we use the same oil distributor that we use for chip seals. But when you're spraying a much lower rate of oil, it's best to have a set of nozzles that have a smaller opening, because to still get your good high pressure coming out of the nozzles. We don't have smaller nozzles, So we shut off every other nozzle, and the nozzles that were left on, we turned more perpendicular to the road to make sure we were getting full coverage. It's the same thing we do when we do our fog seals. And that worked really well. So we didn't have to buy any additional equipment. We just had to make a few minor changes that took maybe 20 minutes, and we were good to go. So I should say we did our sand seal on Lamar County Road 35, 9.5 miles east of Judd, from Judd to US 281. And the project process is the exact same as chip sealing. Broom the road before you apply your oil, spray your oil, then you apply your sand and roll it. And we use the same roll pattern that we do for chip seals. The picture up here on the right, or on the upper right, the right lane is probably an hour after we did the final rollings. You can see the sand is dried out, and you can see there's quite a bit of sand on the road. And then the left lane is right behind the chip spreader after the roller is made, I don't know, 2 or 3 passes. So there's really no different than a chip seal. You're just using sand. We did broom, and then we broomed it the same too. We broomed it the next day after we were done with the project, and then we broomed it again 2 weeks later, or around 2 weeks later, before we did the fog seal. So this bottom picture is the day we did the fog seal. You can see there was still some loose sand getting picked up in the wheel tracks, and I was kind of concerned about that, but it really ended up not being a problem. And then we had a contractor come in and stripe the road when we were done. So the biggest issue we had was with wet sand. So if you remember back in 2019, it rained a lot, and I thought I had picked a good window to move the sand, to stockpile the sand close to the project. Well, after we got the sand stockpiled, it rained for like 2 weeks straight, and so the sand got absolutely saturated. But I wasn't willing to give up, so we went ahead and did the project anyway. And the sand was really too wet. It wanted to clump together. We had to open the gates on the chip spreader more to allow the sand to flow, otherwise it was just going to bridge. So we probably put down closer to 40 pounds per square yard of sand as opposed to 25. So with that, there was a lot of excess sand that once we were done, and you can see when it dried out, all that sand had to get removed, and a lot of it came off in the form of dust. And so right after the project, when we were brooming and from traffic, it was incredibly dusty. And that was really just due to the fact there was all this sand on the road that wasn't stuck to the oil. But since it was so wet, it stuck to itself very well, and it packed like concrete. So the first time we broomed it, it really didn't take much off. We even went out there with skid steers to scrape it off, and the skid steers could barely scrape off the stuff that was really hard. So in the truck hookup, or where we unhooked the trucks, when the truck was empty, there'd always be a little bit of sand that would spill out, and we didn't do a real good job of cleaning those up. We just spread it, tried to level it, thinking, oh, this will broom off, no problem. Well, when the rollers hit that, they packed it, and we essentially had a speed bump every place we unhooked the truck. Now, all this eventually went away after traffic was on it. It rained a couple more times, and eventually all the loose sand, after 2 weeks, when we broomed it, it was gone. And another thing with the excess sand, we had washboards, basically 9.5 miles of washboard. So that was kind of a disaster, and I was kind of worried that we were going to have a road like that forever, but it did eventually work itself out. So this is what the road looked like after 2 weeks, after we did the final brooming, and all the extra sand is gone. There may be a little bit here and there, but it really was a nice road surface. It is thin. If you can see here on the left part of the screen, this is an asphalt patch we did before we did the sand seal, and you can see that easily. It's a really thin layer. It's not very much oil, not very much sand, but it did cover it really nice. You already seen this picture. This is right after the fog seal. And then this is what it looked like late last fall. And it looks the same it looks the same now. So it held up really well. The picture here on the right just shows the texture, and it's just a nice closed surface. I think it has really nice road noise, just really pleasant and even and smooth. just really happy with how it turned out. We didn't do any sealing of any kind in 2020, just due to some budget issues. But in 21, we got good oil prices, and I plan on doing another 15 to 20 miles of sand seals, just because it, from what I've seen for us, it just makes sense. We can do more than twice as many miles as we would with the same amount of oil to chip seal. And for our low volume roads in particular, I think it performs just as well. So moving on to auto seals, we have not done one yet. I wanted to try one last year, but we just didn't have the money. I do plan on doing some auto seals this year, just to try them and see what happens. I first heard about auto seals, it was probably a year and a half ago now. I went to the National Local Roads Conference put on by TRB in Kalispell, Montana. And there was an individual there that presented these, and it was kind of the same thing as the sand seals. The first thing that kind of jumped out at me was there's not real tight specifications on what material you use for your aggregate. Kind of the one thing across the board when I've been researching the auto seal is no matter where it's used, whether it's Norway or Africa or South America or the US, whatever's in your pit, you can use it. And I'll talk a little bit more in detail about what type of aggregate to use here shortly. So that was kind of what piqued my interest. It can also be used as an alternative to asphalt on your low volume roadways. I should say this is really not only, but it's really intended to be used on gravel roads. It can be used on asphalt, really bad asphalt roads. I haven't done a ton of research on that, but I'm coming at it from the point of view of doing it on our gravel roads or roads that were asphalt that we reclaimed to gravel that we would like to pave again, but just don't have the money. So it can be an alternative to hot mix especially on your low volume roadways, your low volume gravel roads. A double auto seal has an 8 to 15 year service life, depending on traffic. That's pretty darn good. That's pushing pavement service life. So that was really interesting. And again, you can use the same equipment for this as you do for chip seals. It's the exact same. So we have everything we need already to try it out. So project materials, this is where the research I've done, it varies a lot on what people have used for oil and aggregate gradations. So for oil, like Minnesota's done a lot of research projects. I know Iowa's done some. I'm sure there's more. Those are the two I've looked at. They have found they have really good luck by using emulsions. So the HFMS2S, CRS2P. We're going to try it with the CRS2P. But then you look outside the US, like in Norway, where this first came about, they like to use cutbacks, and which we don't really use much here anymore. But it kind of seems like it doesn't really matter a whole lot what type of oil you use, as long as it's a good flowable oil, it should work. We're gonna, like I said, we're gonna try to use the CRS2P the first time and see what happens. The rates also vary on what different projects have used. They have had better luck with the higher rates, so I think we're gonna try definitely something in the 0.5 range. Higher than 0.5 gallons per square yard. Because the whole idea is that the oil comes up through, there's enough oil to come up through all the rock and bind all the rock together into, you're basically making asphalt on the roadway. And I'll talk about how to do that here in a minute. The aggregate sizes varies quite a bit, but what it really boils down to is it doesn't really matter too much what your actual gradation is. They just want all sizes, so that you have enough aggregate to kind of lock together and it's not all one size. They're fine with up to 10% fines. It can be crushed or uncrushed. So you could literally go into your gravel pit, use your 7/8 screen and just screen out anything larger than 7/8 or 1 inch, and whatever comes through the screen, use it. That's it, no more processing. Or you can crush your gravel pile and screen out anything that's too big and use that. And pretty consistently, they apply 50 pounds per square yard. So it's quite a bit of material. These are a couple pictures that I pulled from a research project that was done in Cass County, Minnesota. The two pictures here on the right would be your 1-inch max aggregate size. You can see how big the rocks are. And then the one here on the left would be obviously a much smaller max aggregate size. They've had good success with all sizes of aggregates. So it's kind of encouraging to know you don't have to have a real tight spec to make this work. So the project prep, the one thing with auto seals is there's really no structural strength. It's very flexible. So you really don't have much to deal with transverse cracks, since it really expands and contracts really well, but it has no structural strength. So any subgrade issues, you're going to want to fix those. It's not going to bridge over anything. So you fix any subgrade issues, and you don't really want loose material on the surface, like on this roadway here. You're going to want to blade this all up, wet it if you have to, lay it back out, compact it, and seal it. You don't want it time to dry out and then start to gravel out material again and have all that loose material on the surface. So the project process, it starts out just like a chip seal. You spray your oil, apply your aggregate, but where it changes is when you start rolling it. There's a lot of different information out there about rolling. The point is you want to roll it a lot. Like I've read 2 to 3 days. You just keep rolling it. What you're doing is you're kneading the rocks and the oil and working the oil up to the surface, essentially. I think Iowa actually has a kind of a draft special provision for auto seals, and they say in there to roll it 30 times. And then let traffic on it and let traffic do the rest. So the key part to this, though, like I just said, is the rolling. You can't roll it too much. Just keep going. After the rolling, it really varies a lot on how you handle, if you're going to do a double seal, when you do that. But pretty consistently, right after you've rolled it enough, you're still going to have some loose rock come up as traffic is on it. You want to broom that back into the middle of the road or into the wheel tracks so the traffic can work that back in, or you can roll that back in again. But after a week or two, whatever rock is still loose, broom that off the road and then either be done, or you could do a sand seal on it at that point, or do another auto seal, a double auto seal. Some of the information coming out of Minnesota, they saw the best results when they waited 2 to 3 months after the first seal to do the second. But then there's places over in Norway who's kind of the leader in this. They have like 7,500 miles of auto seal in that country. They do their auto seal. If they're doing a double, they do it the next day. It just right away, and they just roll both layers together and just work the oil up through the rock and get essentially one thicker mat. So when I first heard about the auto seal, what I was kind of excited about, where I want to try it and where we're going to try it, is on our county gravel roads where we just can't keep up with the washboard. So you all know where these are: intersections, curves, hills, any place you're accelerating, decelerating, turning, and then also at places where you lose the crown in your gravel road, where you're matching into a flat bridge or a railroad crossing. These are some examples of pictures I took last week in Lamar County. It's kind of embarrassing, especially this one on the curve. You'll lose your lunch going over through this curve at more than 35 miles an hour. And we just can't keep up. There's too much traffic here to keep this from washboarding. So this is where I'm going to try it. So like the 500 feet leading up to an intersection through these curves. Because other than these places, these roads, you blade them once a month, they're fine, except for these places. So we can eliminate these areas. We won't have to run our blades out to these roads nearly as often. At least that's my hope. And then also, if I go back a few slides, this roadway right here, this was paved last spring, or this was asphalt last spring. and the existing asphalt had deteriorated to the point where we like, you know, we're going to grind this up and then use the prairie dog money to pave it. And that's what we were telling everybody that lived on that road. Well, if you're from North Dakota, you know what happened to the prairie dog money for counties. It went away completely at this point. So the $2 million we were supposed to get that we were going to use to pave the 4 miles is not here. And it's like, well, what are we supposed to do? This road really should have pavement. And the people that live on that road, that drive on that road, are expecting that. And so we're going to try to pave, or not, we're going to try to do an auto seal on a half mile or a mile of that road this summer to see if that works. Because that road doesn't see a lot of traffic. I show 100 to 200 vehicles per day on that road. That's probably really generous. It's most days, I bet you it's way less than 100. So, because if that works, that's going to be a game changer for us. And I know it's not, you know, there's no silver bullet, but I'd settle for a bronze bullet at this point. So that's some places that Lamar County is going to try it. And I'm by no means an expert on auto seals. I haven't even done one yet, but it sure looks promising. And it's been used a ton around the world. Like I said, Norway has over 7,500 miles of this, and they do it all the time. So that is the end of my presentation. I guess I'm available for any questions.
All right, Josh, we do have a couple questions here. The first one is, have you noticed any difference in skid resistance, or have you done any testing compared with a normal chip seal?
No official testing, except for just, that was my concern too. But in talking to people that drive that road every day, and I drive it quite often, I haven't noticed any difference. I mean, the surface is, after we fog seal a chip seal, it's very similar to that surface. It might be a little more dense, you know, not as open, but I haven't noticed any difference, to be completely honest.
Great. And let's see, we have another question here. Considering you want to work the oil up through the aggregate by rolling, is hot weather beneficial or necessary?
It is very beneficial, yes. You want it, just like when you're doing your other seals, you want it to be hot.
All right. And let's see, one more just popped up. How long do you expect an OTTA seal to last before maintenance is required?
Well, like I showed, the service life is 8 to 15 years. If it does need maintenance, you would maintain it just like a asphalt pavement. You can patch it. If there is cracks develop, you crack seal it. As far as timing, I think it totally depends on the road and the amount of traffic. Like I said, I haven't done one, so but it sounds like they hold up very well. As long as you do the rolling properly and get good mix on the road, they hold up just fine.
Have you been, okay, one more question. Have you been doing any dust control projects, and how do they perform against washboarding? We've done dust control in Lamar County. I would say not that great. We still get washboards at intersections at these areas, regardless of really what we do. So it's just, you know how gravel is with acceleration, deceleration. It just doesn't hold up. And I would say some of our dust control areas tend to be some of the worst for especially potholes, if they don't get bladed enough. And yeah. All right. Okay, before we move on to our next item on our revised agenda, Dale, do you have, did any other questions come through on your end?
Yeah, thank you, Carrie. Billings County said that they did an auto seal about 5 years ago, that the DOT has plans, and you know, interestingly enough, sitting in the room here with some of the experts, actually the king of pavement, Ken Spadine, and Dan Thompson and Steve McCormick, and the auto seal was used. It's been used for many years. It used to be called a road mix. Sometimes it was almost a coal mix. And the old roadway sections, many of our highways were built foundationally with that type of mix. Does it work? Well, it is. Josh, you nailed it. It is a flexible pavement. What I remember some of the people with institutional knowledge as I started is that the flexible pavement, that type of treatment, when an overlay was put on it and we didn't do our homework well, sometimes we did a thin structural overlay and it didn't perform real well because we didn't have enough structure. So oddly, that thin seal, double seal, and armor coat and auto seal, they operate, they function differently. But we've been using it for a long time. Billings County, congratulations to Jeff and the crew for doing that out west. Thank you, Carrie.
All right, thank you, Dale, and thank you, Josh. Next on our agenda is smart paving, which that goes without being said, right? In North Dakota, that's all we do. But Bryce Worry is going to help us get even smarter. Bryce has always had a passion for construction. In pursuing this passion, he studied construction engineering at NDSU and holds a master's of project management. As the proud owner of Worry Consulting and developer of PaveWise and dynamic density design, Bryce believes technology is the future key to success for the pavement and construction industry. Bryce, take it away.
Good afternoon. My name is Bryce Worry, Worry Consulting and developer of PaveWise. Today we're just going to talk about smart paving using the rolling density meter, and this is a TLN plug. We did here in March a transportation learning network plug on smart paving using technology tools, and this is just one of the tools that we use and a little that we're going to talk about. As we move forward in the asphalt industry, using technologies has become more and more important, and this is one that we really see having a bright future and works very well for producing quality and identifying quality in the field. So I hope you enjoy this presentation on rolling density meter, GPR, and Pave Scan. Just a quick overview of what we are actually going to talk about. We're going to talk about the Pave Scan 2.0 GPR, just a quick overview of what it is, how it works, in case you're not familiar with it. We're going to look at how the Pave Scan is used as a quality control tool. It can be used proactively, like we do as a consulting company, or you can go back and use it to collect data on cores, existing mats, longitudinal joints after the production phase or lay down process in the field. With this tool, what we're really looking for is uniformity. Uniformity, we're finding, is to be becoming more and more important in the design life of the roads, hitting those design lives, just the performance of it and ride. When you can eliminate areas of low uniformity, low density, that road is going to outperform what it's designed for. We're not going to have those maintenance issues that we could have without that low uniformity. GPR project data overview, we'll actually go and look at what this tool can produce as far as screenshots of what we're looking for when running this tool. We'll also look at some projects that we completed using this tool for longitudinal and mat joint density, dielectric comparison. And then finally, what we're just going to go into is the Pave Scan GPR testing, why it's becoming so important and why the industry is starting to go towards this as a testing tool and a quality control tool. So the Pave Scan RDM 2.0 overview. So what is this tool? If you're not familiar with it, it's a tool that collects surface dielectric value. Everything has a value when using the scientific terms of dielectric. Once we know the mix design and we can do a calibration, we get a dielectric of that actual mix. We use that as a constant, and that's how we check for uniformity and compare that to field density. Up on the left, you can see the screen of this specific unit, the 2.0, very user-friendly. We can look at different volumetrics in this screen in real time. And down on the bottom left is actually a 3-scan system, collect more data. So if you wanted to run the swerve method or just be more efficient, you can run all 3 scanners The scanners do collect below them about the size of a baseball to softball size area. They're continuously collecting that dielectric. What the dielectric values indicate is uniformity. So as we walk along, we can actually see that dielectric move up and down. As we find an area that is low, that uniformity is out of the factor, or what we call the baseline. We know that is an area of concern, possible low density. So we typically like to jump there with a nuke gauge and confirm that, or look at using other technologies, IC or thermal, to see if there's an issue in that specific location where that dielectric is found. We can also take cores to calibrate with compaction. It's called a puck kit. It's not quite on the market yet, but what this allows us to do is we can take a gyratory puck or a core and get more accurate asphalt content, air void, and then we can take that out into the field and use it more accurately. We're using that known volumetric to tie down that dielectric and those actual values. There's also an option to collect data viewing void content percentage when you have calibrated on cores. If you don't like to see a dielectric, or you can also look at compaction percent as well. We like to use dielectric. Once you understand dielectric and see what it's telling you, it really can be used, and we like to use it proactively as well. So we don't always have that data from the cores at that time, or there's not a puck quite made yet. So dielectric works well for proactive. If you want to get more into reactive testing or back behind on cores and joint after the paving's completed, you can definitely use the puck kit and get more accurate readings. So that's just a quick overview on the Pave Scan. This is a picture of my personal Pave Scan. I just got a single scanner going here, and this is on North Dakota DOT project Highway 8. So this contractor had a longitudinal joint spec, also had a ride spec on this specific project, but this tool works phenomenal for if you do have a joint or want to see what the consistency of that longitudinal joint is. You're collecting data in real time as you move down that, so you can really look at the uniformity factor and see if we're compacting that correctly. This contractor did use a notch wedge, and those do help significantly with consistency and quality on that joint. This was a phenomenal project. It had some of the best uniformity across the mat, transversely, longitudinally on the joint that we've ever collected with the dielectric, and we'll look at some of that data coming up. But again, this tool works so well for being proactive and finding quality and procedures in the laydown process for contractors. So achieving quality with Pave Scan. It's used immediately after compaction. On-site full data shows the potential of possible low density patterns to be evaluated on-site. So in a proactive manner, we use this right behind the intermediate and the knockdown to look for uniformity. Typically, we cut this area transversely from shoulder to center line. What we're looking for is uniformity, just consistency in the rolling in that knockdown. Then we jump behind the intermediate and do the same, and then behind the finish. So, but what we can find with this tool is our eyes. This actually gives us the data to look at what we're doing. And if we find an issue, we can move forward and look at roller pattern issues. If we're running intelligent compaction, we can look at the maps through that area and see if we were consistently rolling that area. Very important, roller consistency. If the rolling consistency is good, we have to look at a paver issue. We can run, if we're running a paver thermal imaging or anything, we can look at the thermal imaging in that area and look at the transportation, the distribution of it from the plant. Was there an issue at the plant? So what it does, these technologies allow us to evaluate these areas, identify them, and then investigate them. And that's why we like to integrate technology so much into our quality control programs, because you are really finding what you're managing errors and managing the production, the laydown process, and keeping those errors eliminated or low to a point where we can keep a good consistent band. in the field. And that's what asphalt paving is all about, is consistency. So, and that's how we use the Pave Scan to produce these consistencies. And having continuous full coverage information, this kind of information can have a direct effect regarding pay factors. You know, we're decreasing penalties by keeping things more consistent in that band of quality, and also increasing incentives. If you have incentives on a project, and where this technology really shines is with PWL specs, because that specific formula depends on a uniformity or consistency factor. And when you can keep an overall road consistent, when you're coring locations all over, you're not, your band of range of density is a lot lower and typically higher too. So it works really well for if you're going for that consistency uniformity factor. But it provides the data for the contractor and the DOT to see if quality is being achieved, and it allows the contractor to set up a good plan, paving plan, and procedures to hit quality to achieve success on these projects. It is really a phenomenal tool for that reason. So how we use it, we use the Pave Scan as a proactive quality control tool. And what we consider proactive is if we can still make modifications to that mat to improve the quality, then it's considered proactive. The reason the Pave Scan is proactive is it produces data in real time. When we're looking at uniformity behind that knockdown or intermediate, we still have an opportunity to make some modifications to improve the quality. If we have not a very good uniform or a low dielectric in that area out of our band, we can still bring that up. We still have the opportunity to do so in that laydown process. So it provides on-site dielectric values of newly laid and compacted asphalt in real time. And that real time is very important. So we can literally walk around with this thing anywhere, and where sensors we're collecting data there. So instead of getting that data, that 1% data from coring, we can get 30, 40, 50, 60, 70% coverage of that newly laid asphalt and get a better representation of what that road is actually, how it's performing in the laydown process and then the rolling. We have a continuous full coverage map. Provides a full length compaction contour map. We're just getting that data and seeing what's going on in that mat. Core results calibrate dielectric to compaction percentage, void, density, and this is the volumetrics I was talking about earlier. If you don't like to just look at dielectric, you can do your calibrations, you can do your puck kit, and you can actually look at compacted density, compaction percentage, void, if you want to look at that. We do a little of that, but we really do have great success with just using dielectric, honestly, especially in the proactive manner. Typically, that's because in a proactive manner, we don't always have the fully compacted mat in front of us. We're behind a knockdown or intermediate, so we know that mat's not at its fully compacted state. So that's why we like to use that dielectric. Then real-time data allows improvements for quality. You know, we use this dielectric value to look for this uniformity, and you'll hear me say uniformity a lot, but that's very important in paving. That's the consistency factor. Identifying areas of low dielectric. Low dielectric is low density. If we can identify these, eliminate them, manage them, we're building a better road and a more consistent, you're going to get more consistent numbers as you do destructive extractions of cores and PWL specs. And then you can do core calibrations. We typically go back before the core is extracted and shoot 2 time mode dielectric readings in that core location, and then we keep track of this and compare it to the extracted core values, and we'll look at some of that data coming up as well. So here's an example of what you would actually see using the Pave Scan or the rolling density meter, the GPR. This is courtesy of the Alaska DOT. The Alaska DOT has been using this technology for quite a while now. They're kind of the leading innovators of the ground penetrating radar for asphalt. And Rich Giesel up there actually collected this data But what this data is showing here, this is a 3-scan system. Up on the top left, you can see LCR, that's the left antenna, center antenna, right antenna. And they actually have this in a density compaction mode. But look down on the bottom here, you can see the orange, it says example of low compaction area. So you see that fall on 841.25 to 841.50, we got that dip or that fall. When we see that, we know that's a low dielectric. That's a low density area. So what we can do is identify that, mark that, go back and look at our other technology tools, get a nuke gauge over there, confirm that dielectric, that density is low there, and then we can evaluate it and see what caused that low density. Was it a rolling issue? Was it something with the thermals through the paver or the mix itself? It might be even something that is out of our control, a section issue with the aggregate or the base that's being paved on. But what it does is gives us the opportunity to identify it and move forward to try to manage and eliminate these areas. If it's something that keeps consistently happening in a certain area of the mat, say the shoulder every 100 feet, or you know, every so often out on the middle of the mat, well, what is causing this? You know, did we have patching? Did we have, is that where a paver stop and start was? And we see a lot of that, and it's amazing when we start integrating and dropping this technologies of the GPR, the IC, and the thermal imaging on top of each other. Almost always the paver starts and stops, and the rolling starts and stops, and the GPR data almost always match up perfectly for consistency. Where those areas are, the GPR can pick those up, and we identify that, and we try to manage it. But this is an example of a low compaction area using the GPR system. Some more of the data. This is again courtesy of the Alaska DOT, Rich Giesel, but we got the left, center, right antennas. Again, this is a 3-scan system. The actual right scanner is running on that longitudinal joint. As you can see, that's the green down on the bottom. And again, they're showing a density factor in this screen. But starting, well, we're at a 90, which is decent for a longitudinal joint. But as we continue through the stations, 841.25, we're dropping to a point where we're below 80. That's a area, that's a big concern. That joint is going to fail. Well, what's causing this? Why do we have a joint issue here? Was it not compacted correctly? What's going on? This is what we do not want to see on a joint or in the mat. The 2 lines above, which are purple and orange, that's what we look for. That's nice, consistent numbers, dielectric values. We're looking for a nice smooth line, no drops, no peaks. Peaks are also, you know, that means a higher density, but we don't want to see a lot of peaks as well, because if you're working for uniformity or consistency in a PWL spec, those peaks can hurt you pretty bad too in the formula and for pay factors. So we're just looking for consistency, really. And when we find areas that aren't consistent, we mark them down and we evaluate, investigate what caused this. So this is an example of a longitudinal joint. This is the actual video of me running my personal Pave Scan on a longitudinal joint. This is out on a project, and I do apologize. I'm trying to talk under traffic and video and push this, and it does get a little shaky. But what I want you to look at is, this is the contractor used a notch wedge, and the uniformity, the consistency of that line, and that dielectric up there, that's C. So we got a 4.344. So we try to we look for that band. Anything drop below a 4.2 in this specific case, getting off the joint there, trying to push and talk, get back on it a little bit. But we'll look at the screen again here. So 4.40, I mean, very good consistency. We got a couple drops there and peaks, but overall, that's what we're looking for right there. Is that consistency. And coming up here, I'll actually cross the seam line, and you'll see a significant drop, and then I'll cross it back. I'll show you when. Again, I apologize, it gets a little shaky there. Here's the drop coming up. I'll cross the actual seam line into the other right there. So you can see that difference that dielectric actually will pick up on that seam line. There's obviously some real low density there, and then we'll cross back and get 6 inches off that joint. But this is how we use it in the field. That's just an example of actually running it down and going down a joint and what we're looking for. And that's real-time data. I mean, we're walking as we're going, we're collecting data every second as we move that cart down. A lot more efficient, more effective than, say, a nuke gauge. If anybody's ever tried to nuke on a joint, it obviously can be frustrating. You got to sit level if you have any kind of gap or bump there. I mean, it's moving around trying to get that nuke gauge nice and flat, and it's just this way is way more efficient, more data to really evaluate that asphalt section. So here's actually the Pave Scan longitudinal joint data from the project that we were just collecting it on. And what this is just indicating is this is how we go back. We'll shoot the average of the core locations in a lot, take 2 time cores, say there's 5 cores in lot 2. Well, the average of it is actually 4.4. Here, we'll just look at lot 2. So 10 shots, say there's 5 cores, the average in that lot was a 4.4 dielectric collected, timed on those core locations. So then we actually, once we get the extracted results, we'll do the same thing, average them. We break them down and look at them individually, but that's just too much data for us to look at right now in this presentation. But so lot 2, the average core density was a 90.6. And the dielectric from the average of the time mode on those core locations was a 4.4. So we're at a good density there. 90.6 is actually a little bit of an incentive, I believe, in the formula for density, joint density. But then if we go down and look at lot 9, we got a 4.45 average, a little bit higher than lot 2. But our average came back on the extracted cores of 91.2. But what I found really unique about using this tool and on this specific project where we had unbelievable consistency and uniformity across the whole mat and on the joint is look at lot 8, 9, 11, 13, 3. The dielectric average and the core average, there's 4 or 5 days where they're almost identical. And it was just astonishing on this project, walking down 4 or 5 miles and seeing that band so tight on this project and seeing how accurate this dielectric can actually be in comparison to the average cores. And you look at lot 18, 4.62. Obviously quite a bit higher dielectric. Well, the cores came back super high on that in that specific lot, 93.7 on a longitudinal joint. That's pretty amazing. All these are really good numbers. The only one that's a little bit below where we want it to be is lot 5, 89.4 average on the density there, and our dielectric shows that it was lower on an average of 4.33. So it tells us where we are and where we need to be, and works pretty well for that reason. This is the same project. This is just out on the actual mat itself, not the joint. So we did the same thing in the lot. We'd shoot 2 time mode collections in that core location. And then the average core density in the middle is the extracted core average in that lot, and then the very far right, the average median dielectric is the actual swerve method. We go from about 1 foot or 2 off the center line to 1 foot or 2 off the shoulder, and we do what we call a snake method. We swerve back and forth, collecting as much data as we can to get a really good evaluation representation of that mat. But the ones I have highlighted here, lot 6, our average dielectric for the core locations in that lot were 452. The cores came back at a 93.6. The average swerve method dielectric was a 458. So on average, anywhere in that mat that we collected data is pretty close to a 452, or what we can assume, or what we like to assume when we get a lot of data is if we see a 452, that's going to be around a 93.5%. So if we're getting an average of 458 across that mat, we're above a 93.5, maybe even closer to a 94% average anywhere on that mat. So we use that data to really help us know how that mat is performing. Go down to lot 13, a little bit lower that day for the average of 442, but it still came back at a 93.7. So there is a band of accuracy that we have to take into consideration. It's not always perfect, but it gives us an idea. If that was an average of 4.20 average dielectric, we know we got issues and we're going to have some problems with cores and density in that specific lot or that area. But just the way we actually compare the dielectric and use it to the extracted core and the average median to really look at the overall performance of that asphalt. So here we're finally getting into the end, but why Pave Scan GPR testing? Why is this technology becoming so important and popular and trending within our industry? It's a proactive procedure. Again, we can use this proactively behind rollers, use it to really enhance quality in the laydown, the rolling, the whole process in the field. There's no physical damage to asphalt section. We are not extracting cores. The other big thing that's really unique about this tool is we can do it in the boundaries of the construction limits of the asphalt paving. We're not doing it early in the morning or late at night, low light conditions where safety is as big of a concern. Pretty much as that operation's moving down, we can be right behind collecting data. So it's a lot safer way to collect data, and we're getting a way more accurate representation of the entire asphalt section. We really are. When you can collect 25 to 60 to 75% more data just by swerving and using the 3-scan system compared to the 1% you get from cores, you're getting a really accurate representation of the entire asphalt section. You are really understanding what you're doing. You're not making judgment calls based off of 1% of how your cores came back. You are making modifications and adjustments to more than half of what your data is coming back on that mat section. So you're making way better modification adjustment calls for enhancing quality in that section. We're eliminating the guessing game of if quality is being achieved. We're collecting enough data and using this technology to really know if we are achieving quality and how we're doing it, the procedures, the uniformity, and we're just using this technology to be our eyes and collect the data to give us the knowledge on how we're doing. And then modifications made to benefit entire section. We're not, again, making changes to the production or to the process based off that 1% from extracted cores. We're making modifications based off of a lot more data, and I've seen it a lot where we do make adjustments based off of a minute amount of data, and it can actually hurt us. So this just gives us a better idea, better representation of what we have in the field for quality control. It's way more efficient, and just we love this thing for quality, and it has its place really in the industry, and it's going to keep becoming more and more popular. If you have any questions or anything, feel free to call me. But that's it on the rolling density meter. GSSI, I got to thank GSSI and PaveWise for collecting the data and allowing us to use the images. But any further questions on anything here, please reach out to me, bryceworry@gmail.com. Just send me an email and I'll send you my number. We can talk, anything, just feel free. I love talking about any of this. So thank you.
All right, thank you, Bryce. Unfortunately, because of our readjusted agenda this afternoon, Bryce is not able to stay on the line and answer some questions, but he did give his email address there. reach out to him, send him your questions. So for now, we're gonna head into break a little bit early. We'll be back here at 3:15, and we will start right up with Jack Colberg and his safety message. It's 3:15, and we'll give Jack another minute to get his stuff figured out there. I know many of you have probably seen the picture of women in construction as it cycled during our breaks today, and I know Dale mentioned it this morning. In that picture, you will see Nancy Slotten from Border States Paving, Molly Swanston from Swanston Equipment, our one and only gold sponsor for the conference here today, and Sally Miscavige from Otta Construction, along with myself. That picture ran with an article in the Fargo Forum earlier this year, aptly titled, Paving the Way. That article came about, the Fargo Forum contacted me regarding some statistics they had seen about the construction industry and about women in the construction industry, and in particular that the gender pay gap across all industries is 19%, but in construction it is only 3.7%. So again, I am incredibly proud to be part of this industry in this state, and I'm so lucky that I get paid almost as much as a man to work with all of you. So on that note, Jack, how you doing? There it is. I can see it. Sometimes this technology is wonderful. It's bringing us all here together safely, COVID-free, and when it doesn't work, it's a real pain.
So Denise and Jack, I believe you're muted if you can see the little mic symbol. And they're looking, it's got to be small, man. They've got their heads down, they're searching. Oh, they've got IT help. Don't worry, Carrie.
If it's up to me to wing it, I'm gonna resort to those Googled jokes that I told you about.
Oh. Well, I really like the article that you were in. That was exceptional. Congratulations on that, Carrie.
That was a lot of fun, and it was really cool to be in that room with those women. First off, Nancy Slotten, who was the first female president of the AGC of North Dakota, and Sally Miscavige, who is our current and our second female president. And just to hear everyone talk about,
now I gotta start over.
You know, how accepted we have always felt in this industry. It was really neat, and just a credit to the entire industry.
Well, I'm glad you feel accepted, and you certainly should. And you guys are just so awesome to have in the industry. Well, it sounds like we've got some voice there.
Hello, hello.
Yes, I hear you. So Jack, we can hear you. We see your presentation. It is in the edit mode. If you hit the slideshow from beginning.
It keeps wanting to go back. There we go.
There.
Are we good to go?
You are good to go. I think Dustin's giving you the thumbs up. Carrie, we good?
We're good.
You know, it's very interesting in that we're talking about nighttime paving, and one of the things that happens with nighttime paving is things can change at a moment's notice. So here you go, right? It's only fitting. So I drove down from Riverdale, and as it would be, I hit every single red light north on 83 to get to the office here. So away we go. Okay. This is a virtual event, and you know, to start things off, this is the way we kind of looked at nighttime paving. I mentioned this to Dale the other day, and he said first there was daylight, then there was night and darkness, and then someone said, hey, let's pave. So that's where nighttime paving came from. one of the things that we look at when we talk about nighttime paving is worker safety, of course. It's been a major concern because it's believed that nighttime paving can create hazardous work conditions. There haven't been a whole lot of studies that indicate this, but there's been a few things that I think are kind of interesting. RD did a study in 2007 that concluded that most work zone crashes occurred in clear daylight and in good weather conditions. However, a study that was done previous to that in 1998 by a man named Bryden concluded that 1/3 of all the nighttime work zone accidents involved impacts with either traffic control devices or safety features that were introduced into the work zone because of activity. So equipment and people and that sort of thing. However, 37% of those accidents caused serious injuries to both the motoring public and highway workers. So as we move forward and talk about nighttime paving, I think it's critical that we put safety at the forefront and think about how we can get this done without causing either injury to the motoring public or, of course, our folks in the work zone. Nighttime paving, plain and simply, can be dangerous, okay? We can be looking at things like reduced visibility, worker fatigue. One of the issues that we see a lot of times is the fact that we're taking folks and we're putting them into a different operating time frame than they're used to. So can they sleep during the day? Or are they getting enough sleep so that they're not getting fatigued at night? Lighting issues. The position of our traffic control devices and glare from lights can be an issue. Distracted, tired, and or impaired drivers. Road rage. And just as a note, I had something pop up on my screen here. I'm not sure what that is for soils testing. Just as a note, today I went online and I looked at the Vision Zero website, and as of today, we've had 21 fatalities on North Dakota roads, which is 21 too many. I don't know if you folks are seeing that or not, but when done safely, there could be a lot of benefits when it comes to nighttime paving. First of all, in a lot of areas, you're going to see lower traffic counts. You could be looking at reduced temperatures, reduced delays for motorists and construction vehicles. And one of the things that we saw when we were working out west quite a bit in my past career was side access control. So the access roads coming in off the sides, farm to market roads, that sort of thing, were sometimes difficult to control. So you had extra manpower and that sort of thing on hand. It's not uncommon in southern states like Arizona, where it's very routine to do nighttime paving, just because, especially on asphalt jobs, because the temperatures can reach over 100 degrees during the day. So it's difficult to put asphalt down. 2 ways to ensure that there's safe construction is: number one, let's make sure that we properly train our work zone employees, starting with job safety analysis and daily work huddles. Keeping them involved and keeping them in the know as to what's going on is imperative and extremely important. And then we need to insist on maximum retroreflective visibilities of both our traffic control devices and our garments. If we're spraying tack oil, are we putting it on our cones and our tubular markers and our barrels, so that we're actually diminishing the amount of retroreflectivity that we've got on that work zone? So we've got to make sure that the traffic control devices are not only clean, but are in good shape so that they're reflecting well, and that the garments that we're supplying our employees are the highest possible retroreflective visibility that we can get. You know, high visibility is key to nighttime paving. We have to see and be seen, and I think this picture is an excellent job of showing just how the retroreflective garments work at night. Now, the folks in this picture are wearing not only the tops, but they're also wearing pants. That's above and beyond what is probably required, but it's just so important that the motoring public can see our workers in the work zone. ANSI changed the standard for high visibility clothing in November of 2008. They incorporated the changes to include higher square inches of high contrasting colors and the reflective striping that would allow for 360 degrees of retroreflectivity. The changes were incorporated into the Manual on Uniform Traffic Control Devices in 2009. The standard is considered, and this is a little bit of a misconception because a lot of people believe that OSHA is responsible for high visibility clothing, and really they're not. They don't approve anything when it comes to PPE. That's all done through the American National Standards Institute. However, OSHA has an enforceable policy that is compliance, safety, and health officers can enforce in all public access roadways. So real quick, if you look at a vest that does not have sleeves, that is a Class 2 vest. It is for speed limits under 50 miles per hour and is often recommended for daytime hours only. Class 3 is for speed limits over 50 miles an hour and is recommended nighttime hours or hours with low light conditions. Those are the garments, the top garments, vests and jackets, shirts, that sort of thing that have sleeves with retroreflective striping. Step 2, everything we do in the daytime, we can do at night with a few different steps. One being the correct level of lighting, figuring out what kind of lighting we want to use, either diffusers or balloons versus traditional lighting. LED has made a strong entry into the marketplace when it comes to temporary lighting and work zones as well, and most of those are incorporated with balloons or diffusers. Night work is considered a 7-hour period, believe it or not, which includes hours between midnight and 5 a.m. Usually between 11 and 6 is when we see the work getting done. Now that varies a little bit. And of course, as you know, in North Dakota, when we get in these northern locales, the days get pretty long in the heat of the summer and get shorter as we start reaching fall and winter. So that can change a little bit as far as the night work. Night workers should not work more than 8 hours in a 24-hour period where such work involves any special hazards or heavy physical or mental strain. There again, are we night paving a long period of time, or is it something that we're going to do for a day or two or a week or two? That all has a bearing on how our workers are reacting to the work that's being done. Okay, one thing that should be done is a safety management plan. And what we're talking about with a safety management plan is we're talking about something that is going to be looking at what the risks are, what the processes are. You might take into consideration traffic flows, how many trucks we're using, that sort of thing. It's a document that spells out how the work is going to be done. Are we using a pilot car to take the motoring public through our work zones? Are we using flaggers? Are the flag persons at all the access roads, side roads? Are we using 2 pilot cars? We had a project in Wofford City that was really interesting in that the queues were so long that we were using 2 pilot cars, one at the beginning of the queue and then one at the end of the queue, so that we knew where we could turn around and start hitting the other direction. Our traffic control plan. We normally have to have a traffic control plan on every highway job. If we make changes and we all of a sudden decide we're going to start doing some night paving, we have to change our traffic control plan to reflect that. So that's really critical. Are we going to put additional traffic control devices out there to safely guide the motoring public through our work zone? Those are the kinds of things. Where are we placing our lights? Is it a static location? Are we moving? We need to consider all those things in our traffic control plan and our safe operating plan. Best work practices. This is interesting. The Federal Highway Administration published a work zone best practices guidebook, and that has some pretty good positive examples on how to work at night. The website is at the bottom there, and I'll give it just a second if you want to copy that down. It's quite long, and if you're as technical as I am, obviously we had some issues today, so it's Federal Highway DOT work zone practices, best practices, HTM. And we can put that up again if you need to. Are we using mobile barriers? Are we putting up things like Jersey barriers on long-term projects that are going to take a while? That sort of thing, so that if we have an errant driver, we can protect our workers. Okay. A site hazard control plan to consider some of the various factors. First of all is the risks, and those I can't possibly go through all the risks right here, because I'm sure that you folks that have done some nighttime flagging or nighttime paving will think of a few that I don't have here, but some of the things to consider that I've seen in the past are breaks for flag persons. You know, we stick them out there to do a job, and are we letting them have bathroom breaks? Are we letting them, you know, take a little time to have some lunch? Are they getting replaced occasionally? Things like where's the job located? Are we outside of a town? Are there bars? What time do they close? And are we going to all of a sudden have the motoring public that's possibly impaired driving through my work zone? Things like weather, you know, we'll talk about that in a second. The illumination, what type and where? Are we renting lighting equipment, or is it something that we have on hand? Are we making sure that it all works? Is it fueled? Is it, you know, how is it energized? Is it solar panel? Is solar array? Is it diesel? Is it gas? Are we sure that we've got enough stuff to make sure that we can make it through the shift? And nuisances, wildlife. There's a lot of work zones that we have to worry about wildlife. Not just things like deer, but, you know, skunks and you name it. A lot of wildlife becomes active at night, not during the day. High traffic counts, that sort of thing. Like I say, in the oil patch, in the last big boom, the traffic was ridiculous, and at night it just didn't slow down. If anything, it got a little bit worse, because we were looking at things like folks that didn't want to sit in the queue, so all of a sudden they'd take the ditch. So you run into situations like that where it's something that has to be considered, and something that we have to train our employees on. What do? Do they take a license plate number and then call the sheriff's department or the highway patrol or whoever we can? Those are things that have to be considered. Productivity. How many trucks are we using? Our delivery vehicles. Are we putting profilers or rotomills out on the project for a mill and overlay prior to putting the paver out there? How far ahead or how much time do the rotomills have before we can start paving? I've seen projects where the rotomills were out there an hour before the paver was, and then you go ahead and pave. You'd try and fix your production so that by 6 o'clock in the morning, everything was off the road and everything was temporary striped for the next day. And then pilot cars, making sure that folks know that it actually is a pilot car. We're not just grabbing somebody's car off of a crew and saying, follow me. We want to make sure we've got lights, we've got signs, we've got everything that we need to have for pilot cars to effectively and appropriately label them as such. Additional costs come into play. Are we renting additional lighting equipment? Do we put additional PPE on our personnel? Maybe we're adding pants with retroreflective striping instead of just a vest. Is there additional training that we're going to have to do with our personnel? Has everybody paved at night and know what to expect? We don't want our employees to be taken by surprise. We want them to know what they're in for. Objective and relative speed. What's the posted work zone speed limit, and are they actually driving that speed limit? What's the local law enforcement participation look like? I can assure you that a sheriff's department or the highway patrol would much rather have a presence and prevent an accident than having to respond to one. What's the sight distance like? Are there hills? Are there curves? What's the weather like? Earlier this spring, it was not uncommon to encounter some very dense fog on our roads because of the temperature changes. And then the other thing to consider as far as the hazard control plan is the side access, the side road access. Do we have trailer courts? Do we have housing developments? Things like that off to the side, farm to market roads where we have to control that access going onto the road that we're actually paving. So that becomes a little bit of an issue. Okay, light placement. Is it a mobile job? Does the work move forward as the paving progresses? Excuse me. That's kind of a critical area in that if we're doing our work, if we're asphalt paving, we're not sitting still. We're not sitting in one area for very long. We want to keep moving, and our light has to move with us. So it depends on how we're mounting these lights. Are we pulling a light plant behind a truck or trailer, or are we mounting a piece of equipment? Are we equipping a piece of equipment with a balloon or lights? If we're pulling something and it's not being diffused, we have some pretty important glare issues. So we got to be real careful going around curves and hills, especially when you consider somebody that hasn't been there, that's just traveling on this road. They're not local, and all of a sudden they come around a curve. Are they going to be blinded by my lights that I'm using to help pave? So that's a huge consideration. Okay. Here's an example of an LED balloon with a diffuser on it on a paver. It helps a lot to eliminate the glare, and it provides light in a 360-degree radius. Okay, different light levels, and these can be found on your light plants and with the types of bulbs you're using in the plants. Level 1 is a 54 lux or 5-foot candles. And those are supposed to be used for all work operation areas, setup or lane or road closures, tapers, and flagging stations. Okay, those are the lowest level that we've got out of the 3. Level 2 is 108 lux or 10-foot candles. Those go around areas on construction equipment, paving equipment, milling and concrete paste and removal. Level 3 is now we're climbing up to 218 lux or 20-foot candles. Those should be used on pavement or structural crack and pothole filling, joint repair, pavement patching and repairs, installation of signal, electrical, and mechanical equipment. And then just as a note, a foot candle is defined as an illumination is equal to, and I can't see that there, I think it's 1/5 of the square foot of the lux. If we're using the old portable light towers, either the ones that crank up or even have the hydraulic lifts now, those should not rotate outward more than 30 degrees. If we're out more than 30 degrees, we have a really high chance of doing some blinding light and some glare. The other two that we're seeing more and more of are the balloon lighting with diffusers and LED lighting. Here's an example of more than 30 degrees on the left there, the incorrect light angle, and the correct light angle once it's down at 30 or less degrees. We're not only illuminating that flagging station, but we're not blinding anybody in the process. Glare control. All lighting should be designed and operated to avoid glare that affects traffic on the roadway or to workers within the work zone. Okay. Flag person training. We may require additional training for our flag people. And I don't know how many flag people we have here today. Probably not too many, but we probably have some folks that are responsible for them. And I got to tell you, that's the toughest job on a construction site. Toughest and one of the most important. It's boring too, and it may become more boring at night. So one of the things that we have to really be careful about is that we're not seeing flag persons with earbuds in their ears, on their cell phones, their smartphones, listening to tunes or texting folks, not paying attention to the work zone. That's kind of a tough thing. If we're using temp agencies to bring in our flaggers, we have to make sure that they know that what they're doing as far as flagging. It's just critical. We have to review each night's paving to take a look at what was happening in the way of near misses and other problems. Recommendation for Class 3 Level 2 garments. Flaggers in Minnesota, flag persons in Minnesota, are not only required to wear a vest, but they're required to wear a vest, pants, and a retroreflective hat, high visibility hat. As a rule of thumb, practitioners should ensure that motorists can see flagging stations a minimum of 1,000 feet at night. And then we have to worry about fatigue. If it's a short-term night paving project, this can be an issue because people have a hard time sleeping when they're not accustomed to. So it may take a little bit of time to acclimate to different sleep patterns. It's recommended to find a nice quiet place to sleep, close the shades during the daytime, and avoid excess alcohol use when not working. It's tough, you know, to try and change your sleep habits at a moment's notice. So it may take a while to become effective. The last thing that we really want to see is tired workers that are fatigued out on our job site during nighttime paving operations. Think about emergency response. Are there local numbers? Let the local authorities know what you're doing. Let them know that there's going to be some night work. See if they can give you an approximate response time in case something does happen. And then instruct all personnel as far as what they should do, who they should call. Are we looking at the superintendent or the foreman as the person is the first line of contact, and then they're going to contact emergency response? If that's the plan, then how do they get to them? How do they know it's going to happen? So we need to communicate and make sure that we're all on the same page when it comes to emergency response. Some communities that we may be paving by may have only a volunteer fire and volunteer rescue. So they for sure should be brought into the conversation so that they know what they're getting into should something arise. And then finally, I just wanted to bring up the fact that we're looking at April 26th and April 30th coming up real soon for National Work Zone Awareness Week. And this year's campaign is Drive Safe, Work Safe, and Save Lives. And they've chosen they've chosen the 28th as Go Orange Day. So let's keep that in mind. That's the Go Orange Day on April 28th, coming up this month for the National Work Zone Awareness Week. And then just real quickly, because it said night work paving and more, on the more side of things, I think we need to really kind of take a look at our employees. And in a perfect world, we know who they are. We know what they're bringing to work with them. In the way of baggage, do they have something going on that's going to interfere with their job? Are they concentrating on the work that they're doing, or are they distracted in some way? Worrying about somebody that maybe is dealing with cancer, or worrying with things like a spouse that wants a divorce, or bank issues and things like that. If we're going to be working at night, we need to make sure that our folks are in shape and ready to go. If we do these things, I think that we can successfully complete nighttime paving projects. Like I said earlier, there's some huge benefits to nighttime paving. If we've got lower traffic counts, it's cooler. So if it's a hot time of the year, August, July, times like that, when we reach hot temperatures, is it more comfortable actually working around asphalt? So if we are considerate and really take a look at what the risks on a particular job are, we should be able to safely and successfully and complete the job and be profitable while we're doing it. So, thank you. This has been a interesting day. Let's pave.
All right, thank you so much, Jack. I was looking at my notes, and before we rearranged our agenda here, my notes for introducing you included that this presenter, for most of us, really needs no introduction, so then I didn't introduce you. But Jack's reputation does precede him. He is the winner of the North Dakota DOT 2020 Vision Zero Individual Award. He also happens to be the safety consultant for the AGC of North Dakota. Jack semi-retired from Northern Improvement Company after 27 years, serving as Vice President and Safety Manager, where he helped guide Northern to numerous national safety awards and being recognized as one of the safest companies in the U.S. Jack's experience brings a real-world perspective to his safety training, and as an AGC member, you get him for free. So Jack, thank you so much for coming down and joining us today, and thanks again. This afternoon has flown by, and we are now on the agenda item that we have all been waiting for, the awards. So, but before I hand it over to Ken and Matt, I'm going to read their bios because they have earned every sentence in their bios. Ken Swedin became the executive director of the Dakota Asphalt Pavement Association in 2001. Prior to earning his bachelor's degree in civil engineering from South Dakota State University, he worked on various highway construction projects in Montana and Wyoming. He began his engineering career with Texaco Inc. as a project engineer in Houston, Texas. He then worked for the Wyoming Department of Transportation for 20 years as a materials engineer, a resident engineer in Jackson, Wyoming, and a district manager, maintenance engineer in Casper, Wyoming. He then became the city engineer for the city of Sioux Falls, South Dakota for 2 years. Ken also holds a master's degree in business administration from the University of Wyoming. And Matt Linneman. Matt is the materials and research engineer for the North Dakota Department of Transportation. He improves and maintains the quality highways and bridges in a cost-effective manner through the innovative use of materials. Matt previously worked in the DOT Environmental and Transportation Services Division and in the design section of the DOT Support Center, at NDSU. Matt earned a bachelor's degree in civil engineering and a master's of business administration from NDSU. So Matt and Ken, the floor is all yours.
All right. Thank you for that introduction, Gary. Ken, that was a great introduction for Ken, but he thinks he's a little bit shaggy. He's looking pretty good, but he's a little bit shy today. So looks like I'm going to be up here. Just a short introduction of the RIDE Awards, because that's what we're doing right now. Obviously, quality is important to the North Dakota DOT. Ride quality and smooth pavement is very important to our traveling public. So that's what we're trying to work, with our industry partners to achieve that. So with support and sponsorship, of the Dakota Asphalt Paving Association, we've created some very nice plaques here. And so this year we have 3 awards that we're giving out to 3 projects that met a high level of quality and kind of falls under our specifications for 2 or 3 pass opportunities for smoothness. So the first one I'll grab right here is 3rd place. This is the 2020 Ride Quality Award for Border States Paving. This is North Dakota Highway 73 in McKenzie County. So congratulations.
Thank you. Just a quick, I'm happy to have just made the podium, I guess, on behalf of Border States Paving. I think that, not trying to be politically correct, but I think that pretty much everybody involved in the process, from planning and design to construction, deserve a participation ribbon. But I appreciate being able to participate in it, and it's an honor for our company. Thank you.
Well, we can clap here, can't we? Yeah. Virtual flash in the background. We're muted anyways.
Okay, and 2nd place, we have Knife River. This is for a project that was on Highway 83 in Burleigh County, from Wilton south, so Bismarck to Wilton, I think was the stretch here. So congratulations to Knife River. I think we got Danny Schmidt, on the line here from Knife River. So
yeah, I'm on here. Thanks, Matt. An honor to get 2nd place here. That's great. It was a good job, top to bottom. 180,000 plus tons of pavement. The density was great on this job too. The weather was fantastic, which allowed us to do what we could on this job. 36 days of paving, 185,000 tons of mix. Yeah, it was a great job. Thank you guys. Appreciate it.
we'll get this out to you. And so in 1st place, Northern Improvement Company. This is for North Dakota Highway 8 in Twin Butte South area in the Dickinson district. So congratulations, Steve.
Thank you. Well, I definitely had to show up to do a little victory lap in person. This is a real honor for our company. Want to thank NDL putting this conference on. Just a great theme with this year's conference. I want to thank the DOT and DAPA for sponsoring of this award. I think it's great for our industry and it promotes quality. And just hats off to our guys in the field that make it happen. I mean, they came had to overcome about 4 or 5 variables that tough variables. You know, first we were paid the job went from Highway 8 at Halliday up to Twin Buttes. It was in Badlands, hilly terrain, late fall paving. We got behind schedule, so we had to go 24 hours around the clock. Did some Jack's night paving, and with that, it was both a mainline crew out of Dickinson and a municipal crew doing mainline work. And both of those crews had new superintendents and new foremen in their roles. So hats off to those guys. They got her done, and I want to say thank you.
All right. This is clapping for Danny and Mike. I think we missed that. Oh. Well, congratulations to the contractors for the RIDE Awards, and congratulations to the DOT for setting the standard and setting that mark, because we get what we measure, right? And when we set a mark, contractors traditionally will far out compete what we have for a spec. And that's because we have quality contractors in North Dakota. So hats off to you guys. And you know what? The ultimate winner? The ultimate winner is the traveling public. And that's what they're judging us on. The quality of the ride. You know, are they hitting potholes? They have a smooth ride. That's the litmus test for us. So hats off to everybody. Again, can we maybe do a round of applause for everybody? And in the audience, virtual round of applause, scream. Jack, we can see you, so come on, come on. All right. Well, thank you. And you know what? The next event is the pinnacle event of what we have in store for our awards today. And it is because it's a special award. It's an award, a nationally recognized award. It's the first time in this region. And wow, we talked about contractors. We talked about designers, important. The maintenance, the boots on the ground, the people getting it done are so instrumental in making this happen. So without stealing any of the thunder from the key person for making this award, for getting this award into North Dakota, I'd like to turn it over to Kurt Dunn. And Kurt, if you could share a little history with us, please.
Hey, welcome. Thank you. I'm very happy to be able to be here to tell you, to go over some things on Highway 5, some background. And I think it basically also, and how it actually became a, an Asphalt Pavement Alliance Perpetual Pavement Award. So I think it probably happened, a couple of years ago at the Asphalt Conference where Amy Miller was there presenting on a Pave Express software, and towards the end of her presentation, she finished up with a segment on perpetual pavements and how that there are a lot of pavements, existing pavements in the U.S. that actually qualify as perpetual pavements, and so she encouraged us to seek out some of those segments, whether they're on the state system or on the county system. And so I guess, it kind of stuck with me, and whenever my duties where I could maybe do a little research, and I actually found one on Highway 5 I thought would qualify. So I'd like to, I guess where it's located is actually in northeast North Dakota in the Grand Forks District, and it runs from the junction of the east junction of 32 east to Cavalier. Do I have that? Okay, there we go. So I'll show you a map here. Starts up here at just the pointer right here.
It won't
no, it doesn't matter. Okay. So over to the left of the circle there is the junction, east junction of 32, or and Highway 5, and it meanders a little over 11 miles north or east and northeast to Cavalier. Well, I'll tell you a little bit about the roadway. It's classified as a state corridor, and it safely moves people and goods for over 68 years. And it maintains a moderately high degree of reliability and mobility. It supports the movement of agriculture commodities, freight, and manufactured products within the state. And it's actually part of the national highway system. So, well, why was it nominated? And so basically, it's really endured the test of time, and it's maintained an acceptable quality or level of serviceability over its lifetime. And it's endured not only the traffic loadings and stresses, but also the stresses of the environment, such as the thermal cracking or thermal forces and frost action, freeze-thaw cycles, extremely cold winters, and it also was built on challenging soil conditions. And with all those things, it still today performs from a distress and IRI standpoint. So a little bit about the traffic out there. It's about 1,400, cars and trucks a day, with about 14% of those are heavy trucks. And to date, there's approximately 3 million equivalent single axle loads that have went over the road. And it's a lot similar to the other roads there too. I mean, the numbers aren't very high, but the easels are really fairly high compared to other roads too. So Now, I just want to kind of go through like a chronology here of the construction history. And it was graded in 1952. And after it was graded, there was some traffic service gravel put on it so that it would make it through the winter okay. And then already at that time, there was a project already let for the next year, which would actually comprise of the pavement section. Which included the 5 inches of aggregate base and 2.5 inches of stabilized base, and also 2.5 inches of hop-tunes pavement. And there was also a chip seal. That was kind of standard practice that back then too, was to actually put a chip seal on them right away. So they were actually thinking about preservation right off the bat. So then it didn't really receive any. It didn't receive any construction. There wasn't no construction done on it until 1983. So that's 30 years, and there was 2.5 inches put on at that time of hop-tunes pavement. And then 2 years later, there was another maintenance chip seal, and then 12 years later, another chip seal. So it wasn't until 2002 that another 1.5 inches was added to the roadway of hop-tunes pavement. And then in 2006, there was a federal aid chip seal. And then in 2015, there was a mill and overlay, put back, milled off 2 inches and put back 2 inches of super pave hot mix asphalt. And then the last project to date then is in 2019 with a federal aid chip seal in over that. So right now there's about 6.5 inches out there. Okay, so now I want to go over some of the, I saw the chronology, so we'll take a look at the prime contractors that actually did the work out there. And so that it was graded, as I said, in 52 with Joe Mayo and Sons did the work. And then the next year also with the putting the pavement on, that was also Joe Mayo and Sons. And they then also in 1983, Mayo Construction Company put the 2.5 inch overlay on. And then there was a couple of chip seals. We haven't been able to ascertain who those were for sure, so we just sort of left them as is here. So if anybody knows that, we'd be glad to know sometime here. So, and then in 2002, Strata Corporation put down the 1.5 inches. And then the federal aid chip seal in 2006 was Moore's seal coat and trucking. And then Knife River did the mill and overlay in 2015. And then in 2019 was the Aztec Corporation federal chip seal. So that's thank you to all the contractors there that contributed to the success and longevity of North Dakota 5. I also want to recognize and thank the maintenance and construction personnel in the Grand Forks district. They're key to the success also in North Dakota Highway 5 and in all the different capacities that you see there. I also want to give a special recognition and thank you to Rick Kendall and his team out there in the capital maintenance section. They diligently work very hard to keep Highway 5 maintained and preserved. So North Dakota DOT is very grateful and fortunate to work with such a great partners such as the Asphalt Pavement Alliance, the Asphalt Institute, the National Asphalt Pavement Association, National Center for Asphalt Technology, and Dakota Asphalt Pavement Association, and also the Federal Highway Administration. And these are just a few pictures of Highway 5. I don't know if anybody's been up in that country, but it's very, very pretty. It's actually the east or the west end of this section is not too far from the edge of the Red River Valley there. So very pretty, especially in the fall. There's a photo of it coming into Cavalier from the west. Thank you very much.
Nice job, Kurt. And Kurt is the Grand Forks, North Dakota DOT Grand Forks Materials Coordinator, and he has a passion for doing things right. He has a passion for innovation, for going that next step. And Kurt, what I really like too is that, as the director started our event this morning, it's the partnering, it's all levels, it's that boots on the ground, your recognition of the Cavalier crew. Certainly, without maintaining a roadway like this, we can build it to some level of quality. It's not going to maintain and achieve this. So hats off to the crew taking care of it and the contractors that did the work. Kurt, well done in your application, but we need to learn a little bit more. So maybe we could tap into Federal Highway. Lee Potter, our North Dakota Division Administrator, is with us. And Lee, if you could help us understand perpetual payments a little bit.
Sure. I am Lee Potter, North Dakota Division Federal Highway Administrator. Excuse me. First, I want to congratulate North Dakota DOT on a well-deserved Perpetual Pavement Award. It's always nice to be nationally recognized for the work that you do. The Perpetual Pavement, if you don't know what it is, we're going to have a short video here if Dustin can get it running. It'll explain it. That details the principles of a perpetual pavement and why it's the best business practice. And you'll recognize it right off why it is. And the North Dakota 5 example gives you that too, is the limited number of applications of work that was done. There was no full depth reclamation done on that road. So that is the definition of a perpetual pavement. So Dustin, I think we're just ready for that video.
America's public road network spans more than 2.75 million miles of paved roads. This system connects every major population center and is vital to our economy, defense, and mobility. With fiscal constraints and increasing infrastructure needs, agencies are incorporating life cycle thinking into their planning.
It's just like owning a house. Everybody knows that every 18 to 20 years, you're going to replace the shingles on the house. Because once you let the water into the house, the cost of repairing the house goes up exponentially.
Long life pavements, traditionally called perpetual pavements, are pavement designs that provide agencies with an approach that reduces the life cycle costs of a pavement.
So there's a lot of emphasis on keeping the initial cost down. But if we look at the life cycle cost, long life pavements are going to be cheaper in the long run. And then we can clearly see that if we build longer life pavements, we're going to get a lot more for our money.
Long life flexible pavements are multi-layered pavement designs. They are designed and built from the bottom up, with the lower layer designed to resist bottom-up fatigue cracking, which limits damage to the easily repaired surface layer.
So at the bottom of the pavement is where you're going to see the most tensile strain. It's really like the pavement's being pulled apart every time a vehicle runs over it, kind of like a rubber band. And so you want something that's flexible to resist that pulling motion every time it's loaded. A little bit of polymer or a little bit of extra asphalt can be very beneficial in increasing that pavement flexibility, which will in turn increase its fatigue life.
I can fix the top easily, but if my base and my sub-base are the source of my failure, now I have created a huge maintenance issue for the owner and the users in the future. So start with the proper structures, the proper foundation. When you build a house, you have solid footers.
The middle layer uses an asphalt mix designed to support anticipated traffic loads, and the top layer can be customized to local conditions, environment, and requirements.
Good mix designs, good production, good construction practices, make sure you have a multi-layer pavement system that is well built and well bonded between all those individual layers so that it can respond to passing loads monolithically. and then good maintenance, good preservation and maintenance practices on the surface.
Long life pavement design takes into account external factors, so agencies can forecast pavement performance and then specify an appropriate pavement structure for current and expected future needs.
Some of the critical keys are traffic loading, knowing what you're designing that for. You know, the uniqueness about perpetual pavements is that we design it per layer to accommodate the overall loading of the pavement.
So the fatigue endurance limit is central to perpetual or long life pavement design. You have to have an estimate or somehow quantify the level at which cracking is not going to occur. Or if you design it in such a way that the stresses are low enough and the strains are low enough, you're not going to have cracks that initiate and propagate to the pavement surface.
Long life pavements optimize pavement structure through the right combination of thickness and materials. With bottom-up failure mitigated, agencies can focus on the relatively quick and simple maintenance of the surface riding layer. This design approach minimizes maintenance costs and reduces user delays for many highway agencies and owners across the U.S.
The Illinois Tollway, in designing its full-depth asphalt pavements, uses a long-life pavement design approach. We do look at all of the layers of the pavement system. So we've got a number of different full-depth asphalt pavements that I would consider long-life pavements. So we design with the materials and the thicknesses so that bottom-up distress doesn't happen in at least the 50-year design period that we're looking for.
Industry best practices and proven resources are available to help agencies better design long-life pavements and get longer service life from their roads. Some pavement design software applications developed through test track research include features like layered elastic analysis that enable users to design individual pavement layers, taking into account all appropriate variability.
And variability with how thick the layers are, variability in the material properties, variability of traffic. It puts all that together in a Monte Carlo simulation and estimates for you what the strain distribution is. That strain distribution can be compared back against a design distribution that we developed here at the test track to know whether your pavement passes or fails the long life pavement design criteria.
So as we start to look at mechanistic procedures, you can really see how your materials choices impact performance. So as states start to move towards that type of procedure, I think you're really going to see people to be more creative and open to innovation because they'll see the results of performance.
With long life pavement designs, asphalt roads can be built with a structure that lasts many decades, with only periodic surface renewal and maintenance required, making it an ideal choice for drivers, engineers, and the traveling public.
All these have to come together in your long life. It's just not designing a thicker pavement. It's designing a smarter pavement with the right materials and not thinking thicker is always better, because there is a point that you have diminishing returns, that you're just spending money that you don't need to.
Building a long life pavement for the user is really critical because they want to have something that they're driving on that's economical, smooth, quiet, and long lasting. And building it correctly, spending that next incremental dollar, if you will, to doing it that way really does provide the user a long-term performing pavement.
For more information about asphalt best practices and emerging technologies, visit the Federal Highway Administration's website.
Big shout out, thank you to the Federal Highway Administration team, our North Dakota team. Lee, you and the group are so supportive. Thank you for the video, helping us understand what perpetual pavement is and what it could be. And the last word that I heard is it's a smarter pavement. Well, I like that. That's falling right in line with our conference theme. Next up on the docket to share a few words about the award and his accolades to North Dakota who's Pete Grass. He's the president of the Asphalt Institute. Pete, if you would.
Thank you very much. Really appreciate the opportunity to join everyone today, even if virtually. It's best we can do under the circumstances, I guess. And want to shout out to this big audience here that's gathered this afternoon, to a couple of folks that are probably out there somewhere that deserve mention, starting with Director Panos, Wade Swenson, Director of the Office of Operations for you all, Ron Henke, Deputy Director of Engineering, Mac Linneman, State Materials and Research Engineer. These folks, among many others, really worked to make this happen. Folks down at the Grand Forks District, Ed Pavlish, District Engineer, Grand Forks District, Kurt Dunn, District Materials Engineer, District Materials Coordinator for the Grand Forks District, Rick Kendall, Maintenance Area Supervisory, Grand Forks District, Lee Potter, who spoke earlier, Federal Highway Administration, North Dakota Division Administrator, very important, and folks from Napa who helped make this happen as well. And Amy Miller joins us this afternoon. She runs the APA. Importantly, Ken Swedeen of the Dakota Asphalt Paving Association. Ken, you've had a big hand in making this happen, as well as Dale Higland, Director of the LTAP office there in Bismarck. Thank you all. I want to also acknowledge the Asphalt Institute's 2021 chair, Scott House of BP Asphalt, who joins us today. He's part of that virtual audience, as is our senior regional engineer, Mark Blow, who many of you know well. Congratulations from the Asphalt Institute, and thank you for letting us be part of recognizing you with this award, first of its kind in the state. I want to specifically thank Kurt Dunn for putting the nomination in. It's clear that this segment of Dakota Highway 5 and Pembina County clearly met the criteria for the award. And as such, it's deserved and delivered on the promise of providing a safe, long life pavement to the citizens and taxpayers of your state. Will continue to do so, I'm sure, for years to come. It's notable that your climate conditions, your traffic count, and the traffic variety you see are not favorable, and neither is the subgrade. It's a challenge. With no hard rock quarries in the state, it's an uphill fight from the beginning to build pavements that last this long. Well, it takes a village, as they say, from design to construction to the maintenance. It takes the material suppliers, the contractors, the inspectors, and the maintenance teams to fulfill the full investment we make in our highways. And it all matters. And we thank you all for the roles you've played in making this work on Highway 5. Our members there in North Dakota take great pride in their products. The Asphalt Institute members that supply liquid in North Dakota primarily include Flint Hill Resources and Husky Energy, but also McAsphalt, Phillips 66, ExxonMobil, and perhaps a few others from time to time. But they are really thrilled to see you receive this national award today. Thank you for including us, and congratulations once again. Well deserved.
Oh, Pete, that was so nice. Wonderful words. And next up is National Director for the Asphalt Pavement Alliance, Amy Miller. And Amy, as Kurt started off, he said in 2019, your visit to North Dakota started his initiative and search, and ultimately this award. So kudos to you. Thank you for coming to North Dakota and helping us learn. And with that, could you help us understand this a little bit more, what it means to North Dakota?
Sure. Let's just do a test. Can you hear me okay?
Yes.
Okay, very good. All right, Dustin, if you want to run the presentation real quickly, this will just take a minute. right, thank you, Dustin. 68 years old, how about that? So yes, back in 2019, which seems like more than 2 years ago at this point, I had a visit to North Dakota. I got to meet Kurt, and we did talk about perpetual payments. And I remember when I came back from that trip, soon after, Kurt called me and began researching projects. And he was the first state to submit an award that year. And I want to tell you, he did a perfect job of submitting. So just to give you a little bit of background on the APA, I think it's important to know the APA is a coalition of the Asphalt Institute. You heard Pete just talk, the National Asphalt Pavement Association, and the consortium of SAPA organizations. So Ken Swedeen's organization is one of many that represent the State Asphalt Pavement Association organization. As you saw, we began doing perpetual pavement awards back in 2001, and you saw the criteria. Road has to be greater than 35 years old when honored, never experienced a structural failure, never had more than 4 inches of new material, and on average, can be resurfaced any more than 13 years. The winning pavements that we have range in age, obviously at a minimum of 35 years, and we have some that are more than 100 years old. When a nomination is received, we send those into the National Center for Asphalt Technology at Auburn University, and they review those to substantiate the validity of those awards. As you heard from Kurt, Highway 5 was a great candidate for this award and met all the requirements. Again, he did a wonderful job of submitting that award. I'm happy that we're here today, actually able to do this presentation. While we would love to all be there live together, I'm just grateful for the opportunity to have this hybrid event because this is really important. This is your first award, and I'm sure it's going to be the first award of many to come. These awards do represent the longevity and value of long life pavements, and in turn, the value that you're offering your constituents there in North Dakota. So with that, Dale, can we submit the award to whomever's going to accept?
Yes, so Amy, if you would, we have in the audience, we have Dan Thompson, who is the North Dakota State DAPA rep, and he is also on the board of directors for the National Association of Paving Association. And with him is Jeremy Holt, and Jeremy is the president for the Dakota Asphalt Paving Association. These two fine gentlemen will represent Border States Contracting and Anderson Western Contractors. I love this. Two contractors are going to be handing the award to Kurt Dunn, representing the director and all of the North Dakota DOT. Accepting the award again will be Kurt Dunn, the Grand Forks Maintenance Coordinator. So if you would please present the award.
Kurt, on behalf of the National Asphalt Pavement Association, I'd like to give you this award. It's not an easy award to get, and it's a prestigious award, and it is a national award. So, and it takes a lot of documentation and effort to get it done. So appreciate your effort. You deserve it.
Well, thank you very much. North Dakota Department of Transportation is very honored to receive this award today, and it's great to be nationally recognized for something like this, and it's really a commitment from the department and its employees to providing outstanding pavements for long-lasting pavements like Highway 5. So I'm very grateful. We're very grateful to you, Amy and Pete, from the Asphalt Pavement Alliance, and also the Asphalt Institute, Dan, Mark Lowe, and also from the National Pavement Association. Dan, thank you very much. And also from the Dakota Asphalt Paving Association, Jeremy and Ken, and also from the National Center for Asphalt Technology, and also the Federal Highway Administration. Thank you very much from all of us.
Very good.
Okay, and here's the plaque as well. So yeah, congratulations on behalf of DAPA. Kind of puts a stamp in the succeed portion of this conference here. Learn, evolve, implement, and succeed. This is definitely the pinnacle for succeeding. So we're gonna, as an industry, learn what worked here, keep evolving in our obviously 2020, our ever-changing world, and continue to find success. So congratulations.
I also want to thank all of everyone that put this ceremony on today, Dale and Denise, and also Kevin Swerdine and Jeremy and also Matt and Amy from Materials and Research. So, thank you very much. I appreciate it very much.
Don't drop it.
No, it's got a lot of half. It's about 15 pounds.
Hang on.
It's very beautiful. Very good. Thank you. Thank you very much.
Well done, Kurt. Congratulations, North Dakota DOT. And I'm so glad you mentioned Amy is in our audience. Amy Bisey is with the Materials and Research Division. And what I've seen with this group is just an explosion of not only acceptance of new ways, but a passion to achieve, to look at what can be done differently and move in the right direction. And all of that is done. Everything that I'm watching is done in a partnership, a spirit of cooperation with contractors. And that comes from the top down. Director Panos is so focused on partnerships that together we make it happen. So one more time, congratulations for Kurt, the DOT, if we could. Well, love that, love that. Carrie, if we could turn it back to you to bring us home.
Awesome, thanks Dale. Congratulations, North Dakota DOT. On behalf of the AGC of North Dakota, congratulations to all of the winners. The DOT, Northern Improvement Company, Knife River, Border States Paving, nice work. Before we close, I want to give one last shout out for the day to our sponsors. This event is free because of your generous support. Our sponsors today were Swanson Equipment, Ackerman Estival, Bartlett and West, Braun Intertech, Bros Engineering, CHS, Mayo Construction Company, Northern Improvement Company, Team Laboratory Chemical, Altig, Wold Engineering, Anderson Western, Industrial Builders, Tensar, Terracon Consultants, and Webster, Foster, and Weston Consulting Engineers, Inc. Thank you so much for your support. One last thank you today going out to Dustin Ulmer, who is with the Upper Great Plains Transportation Institute's web development. He's the one who technically made all of this happen today. He probably has a few gray hairs from dealing with all of us non-computer literate presenters, but he stayed calm and made this all look very easy. Thank you, Dustin. All right, tomorrow we have a full schedule starting at 9 a.m. Moderator David Farrell with the North Dakota Division of Federal Highway will guide us through presentations on seal coat designs, high friction surface treatments, LTAP's Boots on the Ground program, and developing strategies using road resource. Tomorrow's link is different than the link that you used today, but it is contained within that same email. Thanks for having me, Asphalt Pavers Association. I've enjoyed our time together, and I will see you tomorrow.